Today we're going to be solving a system of nonlinear equations using substitution. As you can see, the problem is nonlinear because we have an x squared and a y squared in the first equation. Sometimes we would consider solving a problem like this by the addition method or the elimination method, but we can't do that in this problem because x squared and x are not like terms, and y squared and y are not like terms. So it's impossible for me to multiply an equation by a number and add them up so that the x's or the y's would cancel. So we really have no choice but to do the problem by substitution. So what we're going to do is we can solve either one of these equations for x or for y, but it's pretty obvious the easiest thing to do would be to solve the second equation for x. So I'm going to add y to both sides of this equation, or we can use our shortcut that says if I move a term from one side of an equal sign to the other, I simply change its sign, and I get that x is equal to y plus 2. Now I'm ready to substitute. I'm going to go to my first equation, and everywhere I see an x in the first equation, I'm going to substitute y plus 2. So my first equation would become y plus 2 squared, because notice it is x squared, so my y plus 2 would be squared, plus y squared is equal to 34. The rest of the equation stays the same. Now I have an equation that has just y in it, and I can solve for y. Now, one of the big tricks to this, one of the most common mistakes for students, is to say that y plus 2 squared is just y squared plus 4. It's not. We do have to take our y plus 2 and write it twice, right? That's what y plus 2 squared means. And then we have to FOIL this. So that would be y squared plus 2y plus another 2y plus 4. We bring down the rest of the equation, y squared equals 34. Now we will combine like terms. I have two y squareds in the problem. Combine those up. I have a 2y and another 2y for 4y, and I have plus 4 is equal to 34. So what I have now is a basic quadratic equation. I have y squared, so it's a quadratic equation. How do we solve quadratic equations? Well, generally we want everybody on the left and 0 on the right. Then we might factor it, or if we can't factor it, we would use the quadratic formula. So rewriting my problem, I now have 2y squared plus 4y. I'm going to subtract 34 from both sides. And that gives me minus 30 is equal to 0. Now, whether I want to use the quadratic formula or attempt to factor this, either way, notice all of my numbers are divisible by 2. And my life is just going to be easier if I divide everything by 2 on both sides of the equal sign. And that gives me y squared plus 2y minus 15 is equal to 0, and this should be easier to solve. Now, I notice pretty quickly, pretty easily, that this is an equation that I can factor. Y squared is y times y. My leading coefficient is a 1, so I just need two numbers that will multiply to negative 15 and add up to positive 2. So that would be plus 5 and minus 3. Now I have my two objects multiplied together equals 0. I set each factor equal to 0 and solve each equation. Subtract 5. So I'm getting y is equal to negative 5, and add 3 to both sides to my other equation, and y is equal to positive 3. Now I have half of at least two different sets of answers. Now notice I don't have an entire answer because one entire answer has to have an x and a y coordinate. So what I'm going to do is I'm going to take my two answers and I'm going to plug them back into one of my original equations. And actually, the easiest thing to do will be to plug it back into the equation that I used for my substitution, x is equal to y plus 2. So if I start off with my negative 5 and plug that in for y, I'm going to get x is equal to negative 5 plus 2, and x is equal to negative 3. So one of my answers, written as an ordered pair, would be negative 3 and negative 5. My second answer would also be plugged into x is equal to y plus 2. So that gives me x is equal to 3 plus 2, and x is equal to positive 5. So my second answer is positive 5 and positive 3. So we have now solved a system of nonlinear equations using substitution. We have two answers. One of my answers is the ordered pair negative 3, negative 5, and my other answer is the ordered pair 5, 3.